developers who don't want to focus on some specific device class like TVs or mobile phones or wearables or IVIs, which were mentioned earlier. Today, I will be presenting to you our new appliance, our automated testing laboratory for embedded Linux systems. I will start with a short introduction of our ATL, embedded testing system. Then I will describe to you what drove us to creating such a laboratory. Then I will present what problems we came across and how we overcame them. I will also present to you our future plans and end with short conclusion. So, introducing our automated testing system. It consists of 6 developer boards, which we run our tests on, and some supporting boards. I wished it always looked this pretty. Unfortunately, once all the cables are completely hooked up, it looks more like this. This photo was taken pretty recently, but let's go back to the pretty picture, and I will describe all the boards by groups. Firstly, there are 2 Mino board maxes, and as you can see, all the developer boards are doubled. We did it for 2 main purposes: to run all the tests in parallel, and to have some and to be able to run tests even if one of the target devices fails. Secondly, and Minoboard Maxes serves us as a target devices for Intel-based architectures, both 64-bit and 32-bit. Next, we've got 2 Odroid U3+. They serve us for target devices, for our reference devices even, for ARM v7, which is 32-bit ARM architecture. And finally, we also have 2 high keys, which are our current reference devices for ARM 64-bit architecture. We still have our options open, though, for ARM 64-bit target devices. We recently investigated if Pines 64 from ARM would suit our needs. We also use some supporting hardware, and these are 2 common, fresh from stock USB hubs to hook this all up. And also, for each of target device, we need our custom designed board, which is microSD card demultiplexer, or SDMax, as we call it for short. And I've got one of these boards with me today, and I will describe it more thorough later. Since I'm completely honest with you today, and I already showed you how ugly it looks when it's completely hooked up, I also admit that these boards are already our second revision of SD card demultiplexer, and our first revision was miniaturized, and it's much more compact and already is used in our setup. So, as the microSD card demultiplexer serves us for many purposes, and why did we have to come up with such a device? What drove us to creating such a board? For most developers in Tizen 3.0 operating system, change lifecycle or new patch lifecycle involves only three roles, and these are developer, reviewer, and integrator. Developer creates patches and then pushes them to Gerrit, which serves us as a review system. Then reviewer checks if a new patch is proper, if it could be merged, and verifies it. Once it is already verified and checked by reviewer, integrator merges new patches to the proper Git repository. And for most of our developers in Tizen, that would be all. That would be complete change lifecycle. For release engineers, it's a little bit more complicated. Integrator, from our point of view, has one more responsibility. Once there is a need to submit some new changes from Git repository to actual repositories for Linux distribution, integrator creates submit request to include new changes into packages which are then deployed to proper systems. Once submit request is created, our Jenkins server sends a request to OBS. OBS is an open build service which serves us for package rebuilds and with package rebuilds including new changes. Also, all dependencies for packages are rebuilt in order to eliminate any build failures as soon as possible. Once OBS rebuilds packages with all their dependencies, new packages are used to create a new image for Linux distribution. New image is then returned to release engineers who test if such an image can be approved and those changes which were introduced in this image would be safe to include it in a new version of repository. As you can see, the role of release engineer is not described on this diagram. Why is that? Because this diagram shows what is already automated. Unfortunately, work of release engineers is not yet automated. And this is what we've been working on for several months now, and this is what I came to you to show. So, as I mentioned earlier, for release engineers, two primary tools are Open Build Service and Jenkins. Open Build Service, as I said before, manages all the packages, and Jenkins serves for other tasks, scheduling, queuing, and managing resources. But what are actual release engineers' roles? Release engineer investigates any build failures if such an event occurs. If there are no build failures and there are new images to check, then those images are tested whether they introduce any regressions compared to older ones. Once there are no build failures and no regressions, we may safely approve inclusion of changes that were requested by us. Unfortunately, this gives us a lot of headache, actually, because all these actions, first of all, take a lot of time. We had to manually download all those images, then test them on every target devices we currently support. And as I mentioned earlier, there are four main architectures we support, which are Intel-based and ARM 32 and 64-bit variants. And then we have to flash all those images onto reference devices and, of course, run our test cases. As you might imagine, these actions are pretty repetitive, they're monotonous. They involve replaying the same set of commands over and over again. And even though they still require focus from us, because test results are often similar one to another, and even slightest change still has to be discovered if we intend to release only well-tested software. So we asked ourselves, if we test all the images on all the target devices for every submit request, maybe we could assume that they don't need to be tested this frequently. We also thought about running fewer tests on our target devices. And finally, we thought that maybe if software builds and images also are created successfully, maybe we could assume that new packages will work properly. Unfortunately, answers to all those questions have to be negative, because it would violate all our basic principles, which are as follows. We try to resolve any issues as soon as they come up. There are no need for postponing resolving them, because the longer the period of resolving an issue gets, the harder it is to find. Also, we always look for a proper solution, not just a workaround, because workarounds do backfire in long term, and we don't want to allow ourselves to do such actions. Also, we don't agree to release software which was never tested or even flashed on an actual device. So we decided that all those images, all those actions done on the images which were our big headache, big problem, have to be automated. And that's what we did. But unfortunately, there were a few problems which we have to resolve while creating automated testing laboratory. We divided them into 4 main categories. First of them is software, and it's pretty easy to resolve, because software issues only involve some designing, some coding, and then we can move on. There are also, one of the examples of software issues was polling Open Build Service for information about new images. Unfortunately, Open Build Service in version which we currently use doesn't support any event mechanism, and we had to work around it. Also, getting images from Open Build Service was not as easy as we thought it could be, because Open Build Service so far served only for humans, and therefore uses only human-readable naming conventions. Those are unfortunately not really convenient for automating actions, and had to be parsed in order to be used in our testing laboratory. A little bit harder problem was controlling testing hosts and targets. Even more headache was given to us by inventing a unified and easy way to publish our test results, because we never wanted to keep them to ourselves. We wanted them to be reproducible, we wanted them to be shared with community, and we wanted them to be reusable for others. And probably the hardest part was flashing target devices with new images. And this is the main reason for creating our custom board. So how did we actually overcome these obstacles? As I mentioned before, OBS doesn't support any event mechanism. There are some plugins which could be used, but unfortunately for our purposes they were not enough. They could only communicate with a single remote server, and we couldn't agree on that. We decided to create another instance of Jenkins server, as we were familiar with this software, and it gave us by default task scheduling, task queuing, and resource management and resource locking. This is all already built in Jenkins server, and since we were familiar with these appliances, we decided that it was the right way to go. As for our internal infrastructure problems, which main of them was reliable communication with the device, we considered first of all OpenSSH to communicate with our boards. But unfortunately, for full operating system tests, it wasn't the best suited. It depends on other services, for example, networking. It also requires a physical network connection, and not all the boards support those connections. For example, high keys, which we still use, don't even have Ethernet ports on board. We considered also serial console, but serial console offers low rate of exchanging data, and it is less flexible than other alternatives. So we decided that there is a need for a new tool which would combine the best of both worlds, and we currently use Smart Debug Bridge developed for Tizen for communicating with target devices. As for managing configuration of our host servers, we started from creating a handbook with Sphinx, which I believe some of you might already know for documenting Python programs. We tried to store all the information in a tutorial or handbook formats, but unfortunately it was hard to keep it synchronized with what we had on our actual servers. So we decided it was not enough for our needs. Also, it didn't give us change tracking for our servers. Synchronizing it for change tracking would require even more actions, which we already want to minimize. So we decided that configuration management software has to be taken into configuration. Currently, we investigate some of already available software for these tasks to give us not only tracking changes, but also improved deployments in new environments, and to reduce number of snowflakes, which are servers which have unique configuration and cannot be reproduced in new environment. As for external infrastructure problems, we had to publish our results, and we wanted them to be easily available, and we didn't want for the users to have to learn new services or have to learn new interfaces. We also wanted our test results to be reusable, and we wanted to reuse existing services. Since most of the documentation for Tizen 3.0 lands on our wiki page, which is hosted on MediaWiki service, we decided that it was the right way to go. And all our test results are published on MediaWiki by PyWikiBot, which is a piece of software provided by MediaWiki for editing and gathering information from wiki pages. This way, we've got an easy way for sharing test environments, information for publishing test results, and for providing data for maybe future reuse. And as for hardware, so far, ways of flashing images onto target devices were specific for every device, for every architecture. We wanted to unify a way, to find a unified way for this action. Also, currently used mechanisms only support single target per host, and we couldn't agree on having each target connected to separate host. Also, it was a rather architecture-specific procedure, and we decided that since we have to support 4 of them, it cannot be done in 4 different ways. Fortunately, all our target devices can be booted from micro SD cards, so we came up with the idea for micro SD card demultiplexer. Micro SD card demultiplexer, but I will refer to this board just as SDMax, provides us with micro SD card slot, which can be redirected either to target device or to host device. But first of all, it has to be controlled somehow by our host machine. It also provides easy access to memory cards, because memory cards and memory cards readers, from our experience, are the most failure-prone devices in such appliances. So we decided that they had to be as easy replaceable as possible. As I said before, a target device can be connected to the multiplexed micro SD card, and also it can be connected to the smart debug bridge from the host device. We also needed a way to reset devices for testing purposes, so we included a power switch, which cuts the power to test the target device for its restart. This way, we had already working new board, but we still needed some software to operate with that. So there is also we also provided SDMax control program for managing the hardware. It provides all the options which SDMax has built in, and is easy to use, easy to script, and from our experience, it serves its purpose well. So from former workflow, where we had to first watch for changes from Open Build service, then build new images by Jenkins, and test them manually by release engineer who, once tests are done, had to publish test results, moved to new workflow involving our SD Max board, which now is fully automated, requires no manual interaction, and saves us a lot of time. Since we liked the idea of SD Max so much, we decided that it shouldn't be only available for us, and since it uses popular standards like USB, like microSD, we decided that it should be available to general audience. So all the schematics and all the hardware documentation is already available at Tizen.org Git server on this address. Also, no proprietary software is necessary for reusing those schematics, as the whole board was designed and prepared for manufacture using KiCad, which is also open source and available to everyone interested. But this is not the end of our work, although the appliance which we created is already in use and already helps us in testing Tizen images. We also plan to improve it by creating pre-test cases for full image testing. We want to eliminate bad images as soon as possible in order to limit time wasted for tests which will only render unusable results. We also want to provide more detailed information about differences between new tested images in order to easily check if there are any and what they are. Also, we want to have an improved failure management. Also, there is a need for reusing some test results which may not appear to be usable from the first sight. And with all those improvements, we also want to have a higher performance, as there are many periods of high load on our test servers. And since this whole appliance is pretty mobile and all these boards which we use are compact, we decided that it would be a great idea to have a distributed system for testing, which could be utilized not only by research and development institutes, but also community who would like to contribute to testing of new target images. So to sum it up, there is absolutely no need for reinventing the wheel while we design and create modern automation laboratory. All the software is already there as building blocks for us. What we still have to do is only give it a little help and manage for our to be easily manageable for our needs. Also, all the enforced limitations, like I mentioned, external infrastructure, can be overcome with just a little of coding. And even though creating custom hardware might be intimidating for new users. It very often simplifies difficult tasks. And all these efforts already proved to pay off since we have much more time to actually develop Tizen 3.0. If there are any questions, I would be happy to answer them.
Tell me, are you making money on Tizen right now?
Currently, I am involved in development of Tizen 3.0, which has not been yet released for any device. It is still developed only for developer boards like Odroids and Mino boards. It is not used in any customer hardware in stock.
So in the future you would like to sell your testing technology?
Our testing technology is fully open sourced and can be reused by anyone. It will be published on Apache 2.0, and anyone who would like to reproduce such a testing laboratory can do it.
Okay, but I don't get the point of Tizen phenomenon. How would you like to monetize it?
Well, I'm developing a platform for further changes for actual devices, and currently I am not involved in any of actions which would monetize it as a product.
Okay, thank you.
How much does SDMax cost? I mean the parts. I assume that it is open hardware.
Yes, that's right. All the hardware documentation is already available in our Git repository. I'm not aware how much would you like to manufacture at once, because cost of manufacturing custom boards strictly depends on the bulk of your of the number of devices you would like to buy. But we use several micro SD slots, regular USB slots, power relay for cutting power, and all those parts are easily available in stock in any electronics stores. But I cannot assume any actual cost as I'm not a electronics hardware seller.
Could you estimate, for instance, thousands of dollars, hundreds of dollars?
Absolutely not, no. It would be a small percentage of price of target device we test on. Thank you.
Hi. You mentioned you're using SD cards, and this is basically SPI as far as I remember. So have you considered like removing the actual SD cards and like emulating the bus over some microcontroller that could actually get the data from the PC, for instance?
We did, but as we want to stay as close as possible to actual devices, we decided that we will stay with real micro SD cards. We want to check if target board with micro SD card installed would behave in real world.
Okay, thanks.
Thanks.
Hi, I have a question. Usually you want to test like from scratch only in certain cases, but wouldn't it be better to, for example, to provide some kind of update functionality to the software you are testing and then use it via like normal network interface? Because usually in the SD card you can, put whole even Linux system. SD cards are quite big, yes. You can put like 8 gigabytes or more. Yeah, this is not a problem, and they are quite cheap. So usually you can put a lot of stuff in. So probably you will be able to make some functionality which can clean up all the SD card. Of course, previously download the software, then put in, and in this way you completely do not need any special access, only normal access for the device. Yes, if the device has some kind of network, then it should be suitable. You do not need any hardware. So for this hardware, I see the usage in most cases when you do not have any access, yes, any like network or similar, or you really want to do it from scratch because your image is completely broken and you are not able to get access via network. But I assume this will be a rare case because you can always have some setup test which checks only that update is possible, yes? And then if it is not possible, you do not propagate on other targets, and then you are clean.
Sure. Your second assumption was completely right. We want to have automating failure management. And if new images with new changes for inclusion render the image completely broken, we want to also have fully automated way of cleaning it up. That's why we not only use software ways of updating operating system, but also have full access to the microSD card.
But it seems that in most cases you are able to skip it. Yes, like, okay, I assume that you have some connections because there are some microcontrollers which do not have internet. But in the like era of Internet of Things, when you have that or stuff which tries to connect the internet, I would assume that most of the devices will have some network connection. So it is quite reasonable to assume that they have some method of update. Yes, and usually you will make partial update like delta update and full update like clean everything and put on. However, from the functionality of the running the device, yes, like you can, for example, clean a whole disk and install everything from the memory. Yeah, this is possible. Okay, this is just to comparison. So then, what you really need is to prove that the update is possible, yes, and if you know that update is possible, then you don't need these devices. You just put normal devices and, test on normal devices without special access. Maybe if you need some special access to some electrical circuits, which you really need to probe, then access, from outside the world, not from the software, would be, needed. However, in most questions, this is the matter of providing the test interface. If you can provide the test interface and update method, most of the stuff can be tested without, any special setup. Just you take, some microcontroller with your SD card, put on USB or whatever, yes, and this is a whole setup without all those boards and stuff like that.
Sure, but as you said at the beginning, we also would like to have a setup for creating an absolutely clean environment. And with direct access to microSD card, we can do it. We can wipe it out, use it on host device, host server to reflash with new image. And that's mainly what we do. If there are no more questions, or I don't see any, thank you for your attention. If any new question shows up, feel free to drop me a line at my email address, which already showed up.